Hi and welcome to another UQ 3D scanning point cloud tutorial. Today we'll be looking at CloudCompare and some of the workflows engaged to get good CAD models ready from your scans. So today we'll just be looking at the CloudCompare interface and looking at some of the tools and tricks to basically get the best out of your non-colored scans and get them ready and good to go to take into Revit or ArchiCAD or whatever you need. Okay, so first things first, we just want to open up a point cloud using this open button here. And we just go OK. And this is just basically talking about the import data that's coming in with the file. Basically we want all this at this point in time. Sometimes you might not want it. If you've got, say, intensity scales you don't want in there for whatever reason, but generally speaking, you just want all this. So you press OK. All our inputs are fine, and our scale is at 1. And there we go. That's loaded up quite quickly there. So this is a subsample version of the original scan. Basically, just to kind of help us out and make it a bit easier to manipulate, so it's not too slow. So as you can see here, the scan we've got has a time-based intensity field, so that you can see through the scalar field. And if we scroll down, it will tell us it's a scalar field for time. And this just basically shows us when each of the elements were scanned and goes from this kind of dark blue to this yellow, orange, I think it's dark blue to red, so that the scan went from here all the way up and back around, of course, because it's a Z1 scan, so it must be done in a loop. So with this data, we can manipulate it in several ways using the scalar field. So now we've got a basic color field. We can have a look at our data a bit better. You can see it's all come through here reasonably nicely. There's been a little bit of erroring, it looks like. And we won't fix that in this tutorial. There are ways you can fix that, but say with this one we just want to get rid of the error data. So this is the later data set. When it's come back, it's errored slightly and is not quite aligned correctly. So to get rid of that, we can do that very easily. Basically, we will cut out that data using our time. So we got all this data, so probably to about there. So we've cut out all the data beyond the yellow, and that just reduces our data set size, and it cuts out all this errored data at the back. Again, you don't get as good density as you would, but for all intents and purposes, that's what we really need. So in order, we can either immediately cull that out, or we can just cull that out temporarily. So using this show n values out of range, it takes your scalar field and shows you and removes all the values that are out of range from your display field. You can also use, if you want to make that change permanent, you can go Edit, Scalar Fields, Filter by Value, which is also this button up here. We just click that. That should, sorry. No, that's not bringing through. So in this regard, we'll actually have to enter those values in. We'll just have to scroll down. Normally that actually takes up data. I don't quite know why it's not. So we can enter those data fields manually. That might be the reason why, because we might have too much. In this situation where you've got data fields with, say, too many digits to edit, you can actually very easily change that, and I'll show you how to do that quite quickly. So we go again to our scalar fields, and we want to go, we want to add a constant scalar field. It's a bit of a tricky one, and we'll just go minus value. And go OK. And then we will call that, say, what's that? 10,000. That we go OK. And then what we can do is we can go Tools again, Scalar Fields, Arithmetic. So we go time divided by the minus, and that will just divide our time scalar field by the minus scalar field. Because that's a constant field, that will greatly reduce our number of zeros. So now we've got a much more easy value to manipulate, and we'll just do that again. We'll cut all that data again. Okay, we'll skip out that data, and then we can go, and here we go. So that auto brings up our values, and we just go OK. And that's created a new element. In most operations in CloudCompare, whenever you make a change to your file, you'll create a new file. This just makes it very easy to edit and manipulate, because CloudCompare also doesn't unfortunately have a back button, essentially, an undo. But that creates a kind of living history. So we got that. We've got a new scalar field out here, and that's quite useful. When we want to take it in, we basically want to not really use these colors. These colors aren't great. So these don't actually tell us a lot of information about what this data is, and we can't really see it. So there's a couple of ways we can colorize this scan. One, we can just use a simple height map, which you just go, colors, height map. And we just go, we'll use the default one, and in the Z direction, we can put that in any direction we want, but generally you want in Z. So we'll just go OK, and we can also set custom colors. And that, we go to RGB, has used the RGB values in there. That can be quite useful, but as you see, it's kind of told us something, but not told us everything. So another good methodology for colorizing the scan is using something reasonably unique to CloudCompare, which is the PCV filter. This basically creates a shadow version, so it applies a light filter. It's got limited functionality, but the functionality is still quite impressive and quite decent. So we'll just quickly show you that one. So that's going there. So only in the northern hemisphere. Just want to go OK, and just press next. And that will process that sound quite quickly, as you can see there, and that will create colorizations. Unfortunately, for some of these scans, say if you want to really colorize what the features we're interested in, which is not necessarily underpass of, the bottom of the underpass over here, we will have to kind of go back and maybe cut that one out. We want that data in there. But it's not too difficult to do. And we'll show you how to do that quite quickly after this. Okay, that's now finished up. So as you can see here, that's come through quite nicely. We can start to see the detail on that expressway, and we can start to see those trees and the underpass underneath here. In this scenario, we might actually leave that one, but I'll quickly just show you how you would do it if you wanted to edit that one out. Edit that expressway out in order to create a kind of, I guess, get more of that data underneath. Which, say if I'm really focused in this heavily in this area down here, I would very much so like to kind of extract that additional bit of data out. So to do that, we want to create a couple of segments in the model. So we'll just go to our top view quite quickly. What we actually do is give it a quick rotate as well, just to get it more aligned to our x-axis. So to do that, we just press the rotate button up here. We want to limit our rotation to the z-axis. We'll just go through quite quickly. And then just once we're kind of happy, it's not a straight scan because it's not a straight, it's a riverbank. So we just go OK, and that's fine. So next things next, we want to go into our front view. We just want to start segmenting the scan. So we want to make sure we're in orthographic projection. Sorry, I'm going to go that front view again. And we just want to cut out that expressway to start with. So the easiest way to do that is to do it via several cuts. So first we cut using our segment tool. So that's just this button up here. And And that just enables us, through the creation of a couple of cuts, arrow's a little bit in the way. Just make sure we've got all an expressway out. Yep, there we go. To kind of highlight the underpass under here. So we create first one of those. A good tip for when you are creating additional scans and you are looking to, say, re-register these, is to make sure that you create it as several components. So what we'll do is we'll create a bottom component, which we created just before, and then we'll create a top component as well. And we'll just split that scan into two. This will enable us to come back and easily rejoin these elements. Okay, close that process down, turn off our original scan, turn off underneath. There we go, we just got a top scan here. So this is great. So from here we could do it a couple of different ways. Unfortunately with this one we've still got some of that data that we want up here, and it's not really quite perfect because of how the expressway slopes. So you can either just kind of leave that as is and just kind of take what data we've got, or again kind of come back and do a bit more editing. So cut that one out, and realistically we want the next bit of data there. So to do that we can kind of look in our right view here. This way, yeah, that's the one we want. We just want to, instead of using our block segment tool, we'll use a bit more of a refined one. And this one enables us to just simply cut out some of the other additional data. We haven't quite got all that one out there, but we'll cut out. So basically in here you just segment it slowly. We segment one piece. One of the big things here, and this is what I've done actually here, is you have to make sure you have the right cloud selected in your database tree. So I'll close that one down again. And the reason why we didn't cut, because we were actually cutting this cloud here. We want to be cutting this cloud here. So again, start again. So we'll just go down, get a bit further down this time. Cut, 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 cut. There we go. And we'll cut that one out. And we'll just move along. Turn it off, pause again, and then we can cut a bit more. And what we actually will do here, because we kind of want some of this side bit here as well, what we might actually find is a bit more useful is instead of cutting it through the side like we've been cutting it just then, is we use our top view, and we'll start to cut up this way. I'll just unpause. Cut that out. Again, cut a bit more. Still. And once we're reasonably happy with what we've got left, we can just press the OK button. And that will segment it into two different spots. This one, unlike the segment tool, does not maintain your original cloud. So as we can see here, we have a remaining and a segmented. So our remaining is the bit that we cut out, essentially, and our segmented is the bit we wanted to keep. So what we can do here is we can combine this one and this one. We've still got some of this overpass here, but I think that should be fine. And we'll just go select both of these two, and we'll just join them back together again. And then we'll just apply a PCV filter to this part. So there we go, that's all come through. And now we can start seeing much better all that detail in that scan, so we can really start making that out well. And that enables us also to see it, so we don't have the scan overpass over the top. And we put that back, that's also there as well, so we can start to see it. As you can see, we do have a little bit of lining here in terms of where those joins happen. And there are some work you can do in terms of cutting out some of your high white ranges and cutting out some of your dark ranges and joining and smoothing those together. To do that, you just use your display ranges parameters and you use your filter points by value tools again, like I showed you earlier with that cutting out of that time area. It does take a bit of work and a bit of melding, but you can get it done. But this is looking pretty good for us right now. I think I'm pretty happy with this one. So that's that scan there. So what I will do, generally speaking, is I will combine those two into one single scan. So just doing the merge multiple cloud tools again. Sorry, I didn't quite point that out before. And that combines that into a singular scan ready for export. The one thing, of course, to remember as well is this has come through is a scalar field. It's not come through as an RGB value. So some CAD suites can register scalar fields, some cannot. One quick way to changing this into a RGB value, if you want to do that, is you basically go Edit, Scalar Fields, Convert to RGB. And you do not want to merge with the existing colors, because if you remember back before, we created an RGB value in our height ramp, and we don't want to combine those two. That would just not quite work too well. So we just go No. And there we go. Instead of a scalar field, that's now an RGB value. So we go back to a scalar field, then we can just go down to change it from the PCV to time. No, we want to turn off this one. And there we go. It's all there. So, putting that back onto RGB, and we can start a bit more editing with the scan. So next thing we'll look at is segmentation, which can be very useful for limiting your dataset size. We already actually covered some of it, but we'll go over it again briefly. And that basically, we can use our cross-section box here, select that, and we can use that to limit the size of our data. So by using this tool, if we're only working with one section of the scan, or we don't need all the extra information, or we're working in sections of the scan that scanned at separate times, we can basically limit the amount of data that's coming in each import. So we just simply, to do that, we'll just cover a quick section. So we'll just do a little mini section for us. I'll just kind of save this bit here. There we go. Just use this one, export section as a new cloud, close down. And then we can go to our front view, and we can see here a lovely little bit of scan. We don't really have much data in here, but we can start to see the rhythm of the underpass and how that kind of interacts. We're in orthographic projection. So this just enables us to have a quick look here. So that's created, that is also a reminder that creates a new file. So you don't need to worry about saving and everything with that when you export. So now we've done that and moving on, we'll look at saving up the file and getting it ready for export. So say I want to export this whole file here, or say I just want to export a section. What I always make sure I do when I'm working in CAD and want to basically work with point clouds, is I want to make sure I keep my bin file here, which is the CloudCompare native format. To do that, at the end when you finish, you basically have to select all your point clouds, and this one too, that one, so that's just done through Shift, and then you just go save. You save in .bin. I won't do that just yet. I'll explain the reason why now. It's basically because we want to make sure we kept our translation data and kept our our location data correct. So as you see in our original import, we imported an angle. So say I wanted to export again, or I wanted to do it a bit differently. Sometimes the location data of my exported scan will not come in through correctly, or say if I would want to go to that colorization and want to change a few things around. This just basically enables I have a failsafe that I can always go back to if I wanted to re-access that color data that I cut out. Here, I can do that. So moving on there, so we just do that, and to export to Revit, we want to close off the clouds we don't want, we just want this one here. So you just need to select it, and then you just go save, and then you can save in LAS, we can save in POY, PST. If you have normal data involved in something you want to keep, you should save in PLY. Generally, LAS or LAZ is pretty good. PTS has indexation problems, and the fact that they index differently in different file systems. I think CloudCompare versus MeshLab index them differently. Though I could be wrong there. So basically, I'll just save it as an LAS, because that's an LAS2. We'll just go tutorial 1, call it the rendered version. And we can just save that. And we want to go original resolution, we don't want to lose any data. And we just go OK. Well, thanks for watching, and if you like that video and you'd like to watch some more, there's plenty of content coming up onto the UQ Architecture YouTube. Should be up now or in the coming weeks. Thank you very much, guys.